Hi, Sarah.
Hi. Okay.
How are you today?
Good, how are you?
Good. All right, what are we going to do today?
More quadratic graphing stuff.
Okay.
So, we went over standard form and intercept form. And today we talked about writing equations and functions.
Okay.
Of the thing. And also I have, I got a quiz back, and I just wanted to see, words. I was wondering if we could go over some of the problems I missed.
Sure. Why don't we start doing that?
All right. So let's see. Some of them I know what I did. They were just dumb mistakes.
Okay. We probably don't need to go over those if you know the mistakes you made.
All right. So oh, I did something weird with one of the ones involving substitution.
Okay.
So I'll do that. It says x squared plus 2y squared is equal to 12. And then 3x squared minus y squared is equal to 8.
You want to solve these the same way we would solve linear equations that were simultaneous. In other words, we want to eliminate one of the variables. How can we do that?
Well, sorry, my computer's opening another program right now. I don't
Okay.
know what's going on.
Can you see my screen?
Yeah, I can. It was just,
Okay.
it hit it.
So what do we need to do to add or subtract these two equations so that one of the variables will disappear?
You can multiply y by 2, or the bottom equation by 2.
The bottom one. It's not y. It's the bottom one. Okay. Now what can we do?
Okay. Now you have to add them together.
Okay. What do we get when we add the left side?
6x squared.
Actually, we have 1x squared plus 6x squared.
Oh, so 7x squared is equal to 28. Yeah. And then 4, and then the square root of 4 is 2, or plus or minus 2.
Plus or minus. I have a rash of students that keep missing these problems because they forget the plus or minus. I told the student last session that I wish I had a stamp, that I could stamp plus or minus on your forehead.
Get it tattooed.
Well, whatever it takes, or a song. I mean, whenever you're taking the square root of both sides, don't forget the plus or minus. Too bad there's not something that rhymes there. But everybody forgets it, so you're not alone. So if x is plus or minus 2, what is y?
Well, then you have to plug plus or minus 2 in for both of them, right?
Well, let's go back to the simpler equation. This one. And plug in plus or minus 2 for x and solve it.
Well, if you plug in plus 2, you get 6, or no, you get 4 times 3, so 12 minus y squared. Sorry, my mom's always weird. Okay.
Is that your ringtone?
No, that's my mom's.
Oh, that's your mom's ringtone?
Yeah. She had her
Okay.
phone in the office. Okay.
Okay. So notice what I did here. I moved the y to the other side to make it positive, and then I moved the 8 to the left side so that I was left with positive numbers. So what's y equal to?
Plus or minus 4?
Plus or minus 2. You have to take the square root.
Yeah.
In other words, when you take the square root, you still have to take the square root of that number, but your answer is plus or minus always.
Yeah.
So we have that. In other words, x can be any combination. In other words, our solutions are actually x equal 2, y equal 2, or x equal 2, y equal minus 2, or x equal minus 2, y equal 2, and the fourth one is x equal minus 2, y equals minus 2. Plug in any of those, and you'll see that that is an equation.
Okay.
So there's 4 sets of solutions, which I guess can be summed up like this. If you just say x is plus or minus 2 and y is plus or minus 2, that should be enough to get that question right.
All right. Okay.
Did you give the answer on your quiz?
Huh?
Did she put the answer on your quiz?
No, he just marks it wrong.
I'm just curious as to what answer he would put. Probably this one right here that I have circled.
All right.
Okay.
Okay. And then another one I missed wants to just solve using whatever method possible.
Okay.
And so it says 2x to the power of 4 minus 3x squared plus 1 equals 0.
Okay. This looks like a quartic. And most quartics would be very difficult to solve. But in this particular case, it's really a quadratic in disguise. Notice that this term is the square of this term. And that's all you need to be able to treat something like a quadratic, is if that term is the square of this. So if I wanted to use u substitution or z substitution, what would I let u equal?
X squared.
Okay, now let's rewrite the thing as a quadratic in u.
Okay, so 2u
2u squared. Notice that if we want to know what u squared is, square both sides.
and then,
So now x to the fourth is u squared.
yeah. Okay, minus 3u plus 1 is equal to 0.
Now let's factor that in u. Not really any other choices. It's got to be minus 1 minus 1. Does that work?
Yeah.
Okay.
Right?
So, yes, it does. So my solutions are u equal 1/2 and u equal 1. So now what?
Now you make those equal to 0, and you solve for it.
Well, now we go up into this, what we substituted for u, and plug in u equals 1/2. So 1/2 equal x squared. What does x equal?
Just the square root of 1/2.
Plus or minus the square root of 1/2. But there's a problem with that. Notice that the square root of 1/2 is the same as the square root of 1 over the square root of 2. And the square root of 1 is 1. So now we're left with a problem. We have an irrational denominator.
Oh, so you have to multiply by the root 2?
Okay,
2
so
over
what,
root 2.
rationalize that for me.
So the square root of root 2, or, no, yeah, square root of 2 over 4, no, over 2.
There you go.
That's
That's correct. And that's always the way it is. 1 over square root of 3 is the square root of 3 over 3. 1 over square root of 5 is the square root of 5 over 5. So when you're rationalizing it and there's a 1 in the numerator, just know you can do that. Okay, so that's our 2 of x values. How many solutions should we have to this polynomial?
4.
Okay, so to get the other one, we're going to let u equal 1 and solve for x.
Then you square root it, and then plus or minus 1, square root of 1.
There's 2 solutions, there's 2 more, there's our 4 solutions. So perhaps one way to remember to put that plus or minus on there is if you did not put it on there, we would only have 2 solutions. That should be a red flag. There should be as many solutions as that exponent. Now, it's possible that sometimes they can be the same, so you might only have 2 unique solutions, but I still think it's a good check when you come up with answers like this to say, well, gosh, we're missing some solutions. I must have done something wrong. What was it? I forgot my plus and minus. Now we have 4 solutions.
Okay.
Notice that in U, I only had 2 solutions because that was coming from this quadratic. So I should have only had 2 solutions. But in X, we should have 4 solutions. I'm guessing if you'd have put one of the solutions as this, you'd have lost a point, but only a point, not the whole thing.
Okay.
Just because this, it doesn't even look like that's the irrational number in the denominator until you break it apart, but it is.
Yeah. I think that's what because I only actually did lose 1 point on that problem, so I'm pretty sure it's for that.
That's probably what you had then, yeah. Okay. So what is this equal to?
Well, that's equal to the square root of 3 over 3.
Uh-huh. All right.
Learning. Okay. Alright, one more is a word problem.
Okay.
And I think I know what I did, but I want to double check. So it says, a rectangular garden measuring 8 meters by 12 meters is to have a concrete walk of uniform width built around it on all 4 sides. How wide should the walk be if all of the concrete is used and there is only enough concrete for the area of the walk to be 48 meters squared?
48?
Yeah.
So this area here is equal to 48, right?
Mm-hmm.
Okay. And the dimensions, we're going to call this x, and we're going to call this x. In other words, the walkway is the same width all the way around, right?
Yeah.
Okay. So how would I figure out the area of the shaded region?
Well, I made an equation.
Remember, shaded region problems are always subtraction problems.
Yeah.
So the area of the outside rectangle minus the area of the inside rectangle.
Oh, that's probably what I did.
What is the area of the outside rectangle?
That is 2x plus 12 times 2x plus 8.
So that, what's the area of the inside rectangle?
40 or 96.
Okay. So now I can write an equation. I can say that this minus 96 is equal 48.
Yeah, so that's the whole deal.
So that's the equation I have to solve. That's just going to be a quadratic. So in order to solve it, I have to put it into a quadratic form and combine all the numbers. Because right now I'm not going to have much in the way of numbers. So what's this multiply to? In other words, I can't solve it when it's in factored form like this. I probably could with a calculator, but in order to solve it, I've got to get it into a complete quadratic equaling 0. So help me out here. Let's multiply these two together.
Okay. So 4x squared plus 40x plus 16
Plus 96. 12 times 8 is 96.
Yeah.
Then minus 96 minus 48 equals 0. The 96's cancel. And now what can I do to simplify it a little bit for factoring purposes?
You could pull out a 4.
Okay. So 4 times x squared plus 10x minus 12 equals 0. Now I can divide both sides by 4. And now I have a relatively simple problem. Back to that.
12 and that's 10. You could do
Doesn't factor, does it?
no, I don't think so.
So you have to use the quadratic formula.
Alright. I forgot that. I just set my equation up wrong. I forgot the 96.
Okay.
Okay. So, book work. I'm trying to find my...
Sorry, what?
I'm looking for my book work now.
Okay.
Okay. Alright, so it has... Alright, so today we learned about the making equations out of solutions.
Okay.
And you have lots of problems. Okay. So I can't find my pencil.
So, in other words, if they say, if you have the solutions like this, what's the polynomial?
Yeah, exactly.
Okay. What are the factors? What are the two linear factors if my solutions are that?
You get x minus 3 and x plus 2
Correct.
is equal to 0.
Multiply that together, you get x squared minus x minus 6. There's your answer. So it's basically just going in reverse. But it's a very key concept to know that if you know one of the zeros, then the linear factor is x minus that. Because after all, had we started with this and factored it, then we would have said x minus 3 is equal to 0, therefore x is equal to 3. Or x plus 2 is equal to 0, therefore x is equal to minus 2. So it's really just going in reverse. Only your problems are probably a little more complicated. They probably give you like 2 plus I or stuff like that.
Yeah.
Well, that's all right. Let's deal with that. Can you find
Okay.
one?
Yeah. Okay. Let's see. So negative the square root of 3 and then comma 3 are your two solutions.
So x equal negative root 3 and x equal 3.
Yeah.
So what are my two linear factors?
Negative root 3, or x plus root 3 of an x minus 3.
And multiply those together. What do we got?
You've got x squared, well, okay,
Let's do
x
it.
squared,
Let's do it by FOIL. Right?
yeah, but then,
Okay. Now we can actually combine those two terms because they're both x's. It doesn't matter that we have a irrational coefficient and a rational coefficient. I'm going to factor that x out. And there's your polynomial. Now, your teacher might want you to convert this to decimal. I don't know. But root 3 minus 3 is just a number. Just like 3 times root 3 is just a number. So there's nothing really wrong with writing it like that. And in fact, that's the most accurate way to write it.
all right,
This is a precise, exact number. Anything else I were to write there would be an approximation.
all right, another one, oh, this one looks fun. Okay, so x equals 1 plus the square root of 3. That x equals 1 minus the square root of 3.
Okay. These come in pairs like this. They're kind of like imaginary solutions. If I told you that I had an x equal 2 plus I, you know automatically that another solution is 2 minus I. Okay?
Yeah.
So this is quite similar with irrational solutions like this. So what are my factors?
X is equal to negative 1, or x minus 1 minus.
Okay, when I say factors, it's not an equation I'm looking for. It's the two linear factors that we're going to multiply together and have it be equal to 0.
Okay, so
So what is x minus that quantity? Like that. And
minus
x
1.
minus this quantity. Make sure you use parentheses. And now let's eliminate the inside parentheses.
So then you get x minus 1 minus the square root of 3. And x minus 1 plus the square root of 3.
And then putting this into a polynomial is just, you can multiply it as if it were a trinomial. And in fact, that's really the only way to put it back together, other than converting these to decimals and multiplying it that way. But let's do it the hard way. Multiply this trinomial times that trinomial. What do we get?
Okay.
Every term, it's not FOIL anymore, because FOIL doesn't really make any sense when you have three terms. But what I like to call FOIL is ET, which means every term by every other term. So what's the first term I get?
Well, x squared.
Okay.
I know you got one of those.
So, in other words, do this methodically. That was that term, and now multiply by that term, and then multiply by that, and just go down the line, each term doing that.
Okay. And then you got x minus x, right? Minus x. And then plus x times the square root of 3.
Okay, keep going.
And then negative x plus 1 plus minus the square root of 3.
And keep going.
Negative square root of 3x plus the square root of 3 plus 3.
Okay, now we have to combine terms. So we only have one x squared. How many x's do we have?
1, 2, 2. Well,
Yeah, we have minus 2x there, and that takes care of that one and that one. And then you'll notice that we have a plus root 3x and a minus, so we can just cancel those. We have a plus root 3 and a minus root 3. We can cancel those. So what have I got left here? Just numbers. Minus 2. So there's my polynomial.
all right.
Now, just for practice, let's factor this using the quadratic. Plug it in.
So, it's negative 2, the quadratic equation, or like factor?
Plug the, in other words, we can't factor that, so we're going to have to use the quadratic to solve it. What I'm trying to do is show you that when we factor this, we're going to get those two solutions that you started with. So
Okay,
let's
so you
plug
have
it in. Minus b is what?
Positive 2 would be minus b because it's minus already. Plus or minus the square root of 4 minus negative 8 over 2.
Simplify root 12.
You get 2 root 3.
And simplify that whole thing.
1 plus or minus 1 root 3.
And that's where we started from. Your
Ooh.
solutions, in other words, your solution was x equal 1 plus root 3 and x equal 1 minus root 3. Right? That's what we started with?
Yeah. So then,
Okay, so that merely confirmed that this was the correct equation that they were looking for.
okay, hold on. Oh, this one's weird because it has radicals and fractions. Okay.
Okay?
1 plus the square root of 2 over 3. And then 1 minus the square root of 2 over 3.
Okay. We're going to do the same thing. What are the linear factors?
So 1, or,
X minus.
so negative x.
No. In other words, if this is the solution, then the factor is x minus that.
Yeah, so then it would be x minus 1 minus the square root of 2 over 3 times x minus 1 plus the square root of 2 over 3.
Okay. Multiply them out again. What next?
Okay. So you have, I'm ready to get down. Okay, so then you have minus 1x minus x plus root 2 over 3x. And then minus x plus 1 minus the square root of 2 over 3. And then minus the square root of 2 over 3 x plus the square root of 2 over 3. Right? No. Oh, and then
The one last term.
2 over 9.
Okay, we're going to multiply this times this.
Negative 2 over 9?
Well, it's negative. What's root 2 times root 2? Excuse me. You're absolutely right. What was I thinking?
I was like, oh God, what did I do?
No, you did it exactly right. I was the one that was doing it wrong in my head. Okay, now as in the last one, we know a lot of these terms are going to cancel, and it turns out that they're always the same terms that cancel. In other words, that cancels with that. That cancels with that. So the only thing we have left is an x squared minus 2x plus 7/9.
Why 7/9? Wait.
Because we have a plus 1 and a minus
2
2/9. Combine those, you get plus 7/9.
Alright. So that's it. That's the
Now, let me think for just a moment here. Yeah, do you have answers on these?
yeah, I do. I should in the back of the book.
Can you look up this one? Is this one an odd one?
Yep.
I'm just curious as if they leave it as 7/9, because you can multiply these by a constant. So I could multiply everything by 9 to end up with 9x squared minus 18x plus 7.
They have, let me,
What do they have for this one?
they have 9 squared minus 6x minus 1 is equal to 0.
Really?
Yeah.
Sure you're looking at the right one?
This was the problem that said 1 plus the square root of 2 over 3, right? Yeah, this is the right problem.
Oh, I put it in there wrong. No, let's see. 1 plus square root of 3 over 2.
Did we? Oh, I think we, no we didn't, did we?
No, we did it right.
It says answers may vary, so.
Well, I don't know how they got that. I can see how you can multiply both sides by 9 to get rid of this fraction, but I don't get I get minus 18x when I do that. It's possible that I made a math error in doing this, although I sure can't see where it is.
I don't know.
Let's try one more odd one like this. Another one like this where we have an answer in the book.
The one that's most similar has an I in it.
Okay, let's do that.
Okay. So 1 minus I root 5 over 4 is one solution. And then another solution is 1 plus I root 5 over 4.
Imaginary solutions always come in pairs. So they didn't even need to tell us this. So all they needed to do was tell us one solution. And the reason I wrote it like that is because standard format for a complex number is A plus BI. There's my A, there's my B. Actually, there's my B. So that's why I put the I afterwards, because I was writing it in more standard format. It's a little dangerous because you can accidentally let that I get under the radical sign, but in order to put it into A plus BI format, you need to do that. Okay, so the other solution is this. So what are my two factors?
X minus 1.
Now, when you subtract this from x, make sure you use inside parentheses, because I'm subtracting that whole thing.
Okay.
Like that?
Yeah.
And then x minus 1 plus root 5 over 4i. And then you'll notice that when we remove the inside parentheses, I end up with x minus 1 plus root 5 over 4i times x minus 1 minus root 5 over 4i. And it always comes out to be like that, so in a way you could just say x minus that and x minus the other one, and you're going to have the right answer. In other words, they're in different orders, but that doesn't matter. So now let's multiply this trinomial times this trinomial. What do we get?
Okay. So, the most fun part of everything. Okay.
Yeah.
So x squared minus x minus square root of 5 over 4i. And then minus x.
Hold on. Don't forget to multiply that third term by x. It was x times that whole thing, so it gave me that. Okay. Minus x.
And then, what was I doing? Minus x, plus 1. Plus 5, square root of 5 over 4i.
Okay.
And then 5 over 4ix.
Notice that term's going to disappear because it's going to cancel with this one. Okay.
Yeah. Okay. And then minus 5 root 5 over 4i. Oh god.
Well,
and then
it's this term times this term.
yeah, so then it would be 5 over negative 5 over 16i.
I squared. Okay. So let's cancel what we can cancel. This term cancels with this term.
And then
What is this equal to? Hold on, did we miss something here? Didn't I have two of these somewhere? Yeah, I have a minus 1 times this, and I have a that times a minus 1. So this term should cancel. Did I cover that up?
No, I think I might have missed it. Oops.
I think we missed it. Let's see, there's 1, 2, 3, 1, 2, 3, 1, 2. Yeah, we missed that middle term, which is going to be a negative root 5 over 4i. When you multiply this times that, you get the plus side. But when you multiply this minus 1 times that, you get the minus side. So we do have two of these terms. They're going to cancel one another out, so I'll erase it. We have two of these terms. They're going to cancel one another out. And now we have x squared minus 2x plus 1. What is this over here equal to? What's I squared equal to?
1, root 1?
Negative 1.
Negative 1.
In other words,
yeah.
I times I is negative root 1. Root negative 1 times root negative 1 equals negative 1. So I squared is a negative 1. And remember that because you always have to convert that like that. In other words, we want to turn this into a real number, not a complex number. And we can because the I squared is real. I squared is negative 1, so this becomes plus 5/16. So our final answer should be x squared minus 2x plus 21/16. Now, they may multiply everything by 16 so that they come up with this. I'm guessing this is going to be their answer, just to get rid of the fraction.
Okay. Their answer was, oh my goodness, what did we do? Okay, so it was over 4, right? Was that this one? Right? The original problem was the 1 over 4 and not just I root 5?
It was 1 minus root 5 over 4i and 1 plus root 5 over 4i.
Their final answer was 8x squared minus 4x plus 3 is equal to 0.
Read it again.
8x squared. Oh, I lost my page. 8x squared minus 4x plus 3 is equal to 0.
Let's see what the solution of that is and see if it's what they say. Use the quadratic.
Alright, so 4 plus or minus b squared minus 4 times 8 times 3 over 16.
Okay, what is this? That's 12 times 8. So that's 96. So this is the equivalent of 4 plus or minus square root of 80, negative 80, over 16, which is the equivalent of 4 plus or minus 4 root 5i over 16, which is 1/4 plus or minus root 5 over 4i. So that's what we get if we take their answer and factor it, which was not what we started with.
They're cheaters.
There's something wrong with their answer. It's close, but it comes out to 1/4. You sure that there wasn't a 1/4 in that at the beginning? Was it maybe?
No.
It was 1 minus root 5 over 4I. Could it have been that? I'll bet you that's what it was. I'll bet you the fractional line. In other words, they were giving you the answer like you would get it out of a quadratic. That's what they were saying. And if this is what we started with, we indeed would have gotten this as a solution.
Okay.
I didn't write it correctly, or you didn't state it correctly, one or the other, but there is definitely a difference. In other words, that's why this format A plus BI is so important, because you don't really ever want to give an answer like this. That's not in A plus BI format. The correct answer, if that was really what they were trying to say, would have been 1/4 plus root 5 over 4I and 1/4 minus root 5 over 4I. As opposed to telling you that x was equal to 1 minus root 5 over 4I. When you read it to me, you put the I in front. So you said 1 minus I root 5 all over 4. So that's probably, in other words, when
that's what they gave the problem.
No, I know. I get the problem. They gave it to you in a weird way. Does it look like this in the book, or does it look like... Yeah. So the fractional bar goes under the 1 also?
Yep, it goes under everything.
Right. Okay. So had I known that, we would have come up with the right answer. It's just, I thought you were reading it 1 plus root 5 over 4I, and you see where that's different.
Yeah.
Okay.
Okay. Book.
Okay. Let's do one more. Try to get an answer that agrees with the book.
All right. These are written differently, these next couple sets, so that'll be interesting.
Okay.
Find a quadratic function. So f of x is equal to a squared plus that one for each parabola described. And it says the minimum value is 10, and the x-intercepts are 1 and 3.
Okay. One of the formats for a quadratic is this. I'm going to use different letters than H and K because I don't mean H and K. In other words, I'm not putting the vertex. It's not H and K. That is the intercepts. So I can say f of x is equal to a times x minus 1 times x minus 3. And the minimum value is the vertex of this quadratic that we come up with. So let's see, if we multiply this out, we get x squared minus 4x plus 3 is equal to our function. And we know that there must be an easier way to do this than the way I'm doing it.
He was telling us today that you find the line of symmetry. Like you find a point between the two x-intercepts.
Okay. So, which is 2.
Yeah.
Ah, so the line of symmetry is 2. I don't need to go through the whole b minus 2a stuff. So if the line of symmetry is 2, that means I can plug in 2 for x and plug in 10 for f of x and solve for a. So I'm going to plug in 10 because the y value at that line of symmetry is going to be your minimum, right?
Yeah.
Okay, so let me unmultiply those together. So I get 10 equals a times plugging in 2 for x gives me 1 times minus 1, a equals minus 10. So now my function is minus, no, hold on, that a is not minus 10. So what did he say at this point?
Well.
In other words, we have the minimum value.
Yeah.
So we have our function. Let's look at this for a moment. F of x equals x squared minus 4x plus 3 as our function. No, let's see. And I put 2 in there. What do I get? 4 minus 8 plus 3 is minus 1. So I need to multiply this whole thing by a minus 10. So actually that was, that a was the minimum. So the answer they're going to give you in the book is minus 10x
squared. Right?
Except it can't be a minimum. If it opens down, it's a maximum. They say the maximum was 10 or the minimum?
Oh, maximum.
Ah, okay.
Maximum value 10.
Okay, so we do know that it opened down. So here's what they're going to give you as an answer. Hopefully. Hopefully I get one of them right.
Let's see. He was telling us today in class to be a little wary of the answers in the book.
Yeah.
Because they can be a little, yeah. Oh, look at that. Yeah. F of x is equal to negative 10x squared plus 40 minus 30.
Okay. Yeah, that was a very helpful technique, knowing that our intercepts were 1 and 3, therefore the line of symmetry has to be halfway between that 2, and if you plug 2 into this, that allows you to solve for that a, which was minus 10. Okay.
All right.
You have another one like that by chance? That'd be another one to do, a good one?
Yeah.
Okay, let's do that. Be done with it. Here.
So, let's see. Minimum
Okay.
value of negative 8.
That means it's this kind of parabola. So our final answer needs a positive coefficient in front of the x squared term. Okay. What are
The
the
x-intercepts are 0 and 8.
Okay. So the line of symmetry is what?
4.
Okay. And our function, what's the general format of it?
F of x is equal to ax squared plus bx plus c.
Since we know the intercepts, there is a form for a quadratic that looks like this, where h and k are the two intercepts.
Oh yeah, we were using that in class. He called
Yeah,
it the intercept.
so let's use that. So
Okay.
I want to plug in 0 and 8. So there's our equation, which is a times x squared minus 8x. So there's our function. And when I plug in x of 4, I get minus 8. So minus 8 is equal to a times 16 minus 32. Do you see everything I've done there? I should let you do it. I forgot.
Yeah, no, I get it.
Okay, so that's minus 16. So I want to divide both sides by minus 16. So a equals minus 1/2. Excuse me, plus 1/2. So my final function is what?
So 1/2 x squared plus the, wait, I have this in the notes.
Okay, go to this one right here and plug in
Yeah, so
1/2 for x.
minus 4.
Minus 4x. And there's our function.
And then that's it? Because there's no, yeah, okay.
Right, because there's no constant term.
Yeah.
Because one of those intercepts was 0.
So if an intercept's 0, there's no constant?
I guess, yeah. That makes sense, because then you're going to have an x times that, and there's no constant produced.
Okay.
All right.
All right.
Those were interesting problems.
Yeah.
I don't know if we missed 2 of them, or the book missed 2 of them.
We'll see. He always, like, he asks if you had any questions on the homework.
Uh-huh.
So I'll ask and see if...
Okay, the one we missed, actually I know why we missed it, because I wrote it wrong. In other words, the one where it was 1 plus root 5 over 4i, and it was actually that. So
Yeah.
we didn't miss that one, I just wrote it wrong. But the very first one we did, maybe I did the same thing on that first one. Maybe the denominator went under both numbers. Oh, I bet it did. Sure. That makes sense.
Does that make sense?
The first problem where we did that was of this nature, I might have erased it. No, I don't remember. But anyway, that could have explained. Oh, it's this one here. I'll bet you this 3 goes under both terms. That's why we...
No, in the book it has it written that way, with just the...
It has it written like this?
Yeah, with just the, yeah, just like that.
Huh?
With only...
All right.
the 2.
Well, either I made a mistake then, or the book's got the wrong answer on it. So that's the one you probably want to talk to your teacher about.
All right.
Okay?
I'll ask him tomorrow.
All right,
All right,
Sarah.
thank you.
You're welcome. Talk to you later. Let's see, do we have another one set up yet? We got Saturday. Sunday's at 3.
No, I think Monday now because we moved it, right?
Well, now, did we move it permanently? Is that a permanent change?
Yeah, I think so. Right.
I think I did do that now that I think about it. Yeah, I don't have...
Are you all right with next week because it's break?
Okay, so we don't want next Mondays?
No, yes, or no, because Thanksgiving too, or Wednesday. At least not next Wednesday, because that's...
Just not... You're going to school Monday?
No, we don't have school Monday.
Okay, so do we want Monday's appointment also?
No, because, I mean, there's no school.
So we're going to cancel both of them, and David also won't need a Wednesday appointment for sure. So let me cancel that, and then I'll cancel your Monday one here too. And that's just canceled for next week. So I won't talk to you again until next
Next Monday. Till December.
And I don't, I got to put you in down there for that too. It's Monday at what time?
At 5:45. I think
5:45. Okay.
45, yeah.
Okay. I'm going to hang up with you. Tell David I'll be with him in a minute. I got to take care of your scheduling here, though. I got to get a plan on these Mondays. Thank you. Talk to you later.